In this video, we are going to continue our discussion on the dot product. In this video, we will look at the properties of dot product and work some examples out. So it is commutative, meaning the dot product of u times u dot v, that's how we say it, u dot v, is the same thing as v dot u. It's also distributive, so notice here, this is being dotted with a sum. It works like this, like you would think you would want it to work. I dot both of them and I add them together. The constant, unfortunately, just like multiplication, it doesn't go to both. Like if I do 3 times 5 times 2, it doesn't do this. That only does that with multiplication. But I could do this in any order, right? I could do this instead. That's what that's saying, but just with a c and two vectors. 0 times dotted with a vector is 0. 0 vector. And then this one is great. V dot V is the same thing as the magnitude squared. Think about this. V dot V, let's actually do it real quick. Let's call it V1, V2. Let's keep it easy in 2 dimensions. If I do V dot V, all right, so V dot V, I would do it with itself, so it's V1 squared plus V2 squared. Now if I take the magnitude and I square it, this is the square root of V1 squared plus V2 squared, but the square squares that and gets rid of it. So it's the same thing. We're going to use that quite a bit. Actually, here in a moment, we're going to use it to derive something else. Okay, so now we believe, hopefully, that those are the same thing. All right, so we have all these properties here that we're going to use for this example. Okay, so we can distribute that v through the dot product, or we could add them first. It really doesn't matter. I guess for the sake of dot product practice, let's write it as a distributing problem. So this is v dotted with w plus v dotted with u. All right, so this is, and I just write these out, v is 2, negative 4, 7, dotted with w, which is 3, 2, negative 7, plus v, again, 2, negative 4, 7, dotted with u, which is 2, negative 4, 1. All right, this just multiplies component-wise, so 2 times 3 is 6, plus 8, minus 8, negative 4 times 2, minus 49, plus, and then I do this dot product, 4 minus 8, plus 7. All right, if we add all of that up, all right, so negative 2, negative 51, negative 47, negative 47, negative 40, negative 48. I think it should be half that. So there's somewhere I messed up. So I'm going to give you this answer. I got negative 24. Something's not jiving here. All right. I would look at that answer. You can see the way that we're supposed to do it. I got negative 24 in my notes. If we follow this, I think there was some mistake I made somewhere in there just now. Oh, I found it. This is a negative 16. I don't know if that helps, though. Oh, it's a positive 16. There we go. Now it works. Great. Be careful. A lot of the mistakes I had to say in Calc 3, for me, even like teaching-wise, simple mistakes like that, just be very careful. All right, so there we go. We have that. Now we have a dot product times that. We're going to do this piece by piece. So let's do that. I got v. I'm going to write that down. 2, negative 4, 7. Dotted with 3, 2, negative 7. And then we're going to times that by the u vector 2, negative 4, 1. All right, so we have, and this isn't a dot here in the middle, and you'll see why. All right, so we do the dot first. Okay, so we got 6 minus 8 minus 49 times this vector. So notice now we get this number. Okay, so it's negative 2, negative 51. Let me get my notes. Negative 51 There we go. Was not writing for me. Times that. So notice this is not a dot product because it's a scalar times a vector. I multiply this through. I get negative 102, 204, and negative 51. All right, so there we go. Okay, so now we're going to do C. I do piece by piece. So let's do V. Let me show this first. V minus W squared. All right, this is the same thing. Let's actually find V minus W first. Let me move this down. My apologies. V minus W. Let's do that. All right, V was 2, negative 4, 7. Minus W was 3, 2, negative 7. So we get negative 1, negative 6, and 14. Be careful, that's not 0. Okay, so now, if I follow this property, this falls under number 5. That the magnitude squared is the dot product. So this is the same thing as V minus W dotted with V minus W, which is what we just found. So this is negative 1, negative 6, 14, dotted with negative 1, negative 6, 14. Dotting that, we got 1 plus 36 plus 196, which is equal to 233. All right, that was that first one. I'm going to do the second one now. So we need a V plus W. All right, that is 2, negative 4, 7, plus 3, 2, negative 7. And I add these together, I got 5, negative 2, 0. All right, now I do the magnitude squared. We know that is just the dot product of the two. Of the thing again, twice. All right, that is 5, negative 2, 0, dotted with 5, negative 2, 0. That ends up being 25 plus 4, which is 29. And then now we actually can answer the problem. We did piece by piece. We have both of these. Just a warning, because my hand's cramping. There's a lot of writing in this class. It's a lot. A lot of rewriting, just the vectors, having to do all the arrows all the time. Just letting you know, it does pile up. Okay, so there we go. That's how we use the properties of the dot product. Like I said, we're just kind of playing a game. You're going to see how these are useful as we continue through the course.